So this video is on the chapter 4 MA classwork number 14. And I'm going to run through these. Again, this is meant to be a guidance if you're having trouble, but I'd like for you guys to try them first. So in this situation, we have a Ferris wheel called the high roller that has a diameter of 520 feet. Okay, so diameter of 520 feet. It makes a revolution every 30 minutes. Okay, so that's going to be important because that's going to mean my period is going to equal 30 minutes. So period equals 30 minutes. Knowing that my diameter is 520, if I take half of this, that's going to be 260 is going to be my radius or my amplitude. Okay, I'll put amp. And I know that the center of this Ferris wheel is 290 feet above the ground. Okay, so the center is 290 feet above the ground. That's going to be my K. Okay, that's going to be my K. My K is going to be 290. How long after reaching the low point is a rider 433 feet above ground? Okay, so how far or how long after a low is a rider 433 feet above the ground? That is what we're going to be trying to figure out. So for this, I'm going to draw my picture. I know that my center of my Ferris wheel is going to be 290. I know that the diameter is 520, so that means the radius is 260. So I am going to move this over here. I am going to take 290 plus my diameter, which is 260. That's going to put me up at a high of 550. And I'm going to take 290 minus 260, which is going to give me my low, which is 30. Okay. So that's what I have so far. Okay. So now, in this particular case here, let me just, this is going to be all of my zeros. Okay. This is going to be all of my highs. This is going to be all of my lows. So we want to know after a low, how long does it take to reach 433 feet? They aren't telling us where any of this is starting. So I'm going to start my low at 0. That way it's going to be easier for me to calculate after my low, when's the first time I reach 433. So that's going to be my first point. I'm going to have 1, 2, 3, 4, 5. This is going to be 30 because I'm starting at 0 and my period is 30 minutes. So I'm going to be going 30 minutes beyond 0. I could plot this graph right now. This is what it's going to look like. I'll figure out all of the values here in one sec. Okay. To figure out this one here in the middle, I average 0 and 30. Half of 30 is 15. Okay. 0 and 15. Half of 15 is 7.5. Average 15 and 30. So 45 divided by 2 is going to give me 22.5. And that's my graph. Now, I'm going to, in purple here, let's just say 433 is here. Okay. So let's say that this is 433. I'm not drawing it by scale. I'm going to be trying to figure out that X. What is that X? Okay. So let's write an equation for this. So I'm going to do a cosine. It's going to be a negative cosine because I'm going to be starting down here at my 30. So my amplitude, okay, is my radius or the distance between these two lines, which is 260. So I'm going to have a negative 260. My period is 30 minutes. So I'm going to take 2 pi over b equals 30. So I get b is equal to 2 pi over 30 or pi over 15. So I am going to have my cosine of pi over 15. And again, I am starting, oops, pi over 15. I am starting at this point right here. Okay, that's where I'm going to start. So that's at 0. So that means I'm going to just put x, and then my vertical shift is 290. So that's my equation. So what I'm going to do now is I'm going to put this equation into my graphing calculator in y equal, making sure it's in radians. And then I'm going to put the line y equal 433. I'll put that equation in. So let me get that into my graphing calculator. Okay, I'm going to put it in y equal. And so I'm going to go negative 260 cosine of pi over 15 times x, okay, plus 290. And I'm also going to put in y equal 433 so I can find the point of intersection. Now I'm going to adjust my window to look like my graph on my paper. So I'm going to press this window button, and I'm going to change my x's. I'm going to go from 0 to 30. Okay, and sometimes you might want to go a little beyond if you need to see more of the graph. But I think this will be fine for this question. And I'm just going to go by ones. And then my y, I'm going to go 0 to 550. Again, that's going to be the ticky top. Sometimes maybe you want to go beyond it. Maybe I'll go to 560 just so we can kind of see that. I don't want to go by ones. They'll just give us solid tick marks the whole way. Maybe we go by, let's say we go by cookies. It doesn't really matter. It's just more or less tick marks you can see. And then hit graph. And here's our graph. That is our cosine. It's going to be graphing our y equal 43. And I want to know this point right here. So to find that point, I'm going to go and try to find the point of intersection. To do that on these calculators, I'm going to hit second and trace for the word calculate. And number 5, okay, I'm going to arrow down, but you just press 5. Number 5 right here, intersect, that's what I want. And it's going to ask you first curve, second curve. I'm trying to find the point of intersection over here. So we want to move this to be where the point of intersection is we want to find. Right now, if I arrow left or right, I'll be moving on this curve. If I arrow up or down, and the arrow buttons I'm talking about are these ones here. So if I arrow up or down, I'm just going to, doesn't matter which one, it's going to drop me to the line. I'd rather travel on the line than the curve. It's a little faster to get where I want to get. And I'm going to go to where the point of intersection is. You don't need to be perfectly on it. You just need to be close to it. It's going to ask you, oh, is this your guess for the first curve? You're going to hit enter. Okay, this is what that same x would be on the second curve. You hit OK, enter. Then it takes a guess. You hit enter. And there's our answer. 10.28 is when the first time after this low, because it's started low at 0, 10.28 is going to be our answer. Okay. So it's going to be our answer 10.28 minutes. After the first, after a low, will it be at a high? Okay, next problem. Next problem is a little bit more complicated. So on this one, some math analysis students ripped their graph of a sinusoidal curve so that they only knew a maximum occurs at 2 and a minimum at 5. Lincoln concluded that the height of -5 was first arrived at 1.456 minutes, 7 minutes. Use symmetry to calculate when the next 2 times the height is -5. Sketch the graph, label all important values, then answer the question. Okay. So for this one, I'm not going to draw a X or Y axis, okay? I am just going to draw a curve, and let me just kind of start at my high. Okay, so let's say that this is my high. Don't know what it is, but I know it's 2 comma whatever my max is going to be. Don't know what it is. Okay. And so what's going to happen is I'm coming up to here. Okay, that's my max. I'm going down and back up. And I know my minimum is going to be at 5. So this is going to be 5 comma whatever our minimum is. Not sure what it is, but I know it's going to occur at 5. Okay. So for this, I also know that the height of -5 first arrived at 1.4567 minutes. Okay, so I'm just going to draw in. Let's just say that this is our -5. So this is y equal -5. And so this one occurs at 1.4567 minutes, comma, -5. I need to figure out when the next 2 times it's going to be. So I need to figure out this one and then this one. And here, I'll find this one too, just to show us how to do this. Okay, so what I'm going to do is I know that from here to here, from here to here, this distance from here to here, I can figure out by taking 2 minus 1.4567. And I get 0.5433. So this distance here is going to be 0.5433, which means, I'll just do it in a different color, but from here to here is also 0.5433 because of symmetry. So I am going to add onto this 2, because that's x is 2, 5.433. So when I do that, this point right here is going to be 2.5433. That is the first time after that I'm going to have, the first time after that I am going to have a point at a height of -5. Now that I have this, what I'm going to be looking at is if I knew my period, I know that if I go from here, which was my first 0 on my way up, to here, which is again my 0 on my way up. Not 0, but my -5 on my way up, and then this is the same spot here. This needs to be whatever the period is. I don't know what the period is, but I can figure it out because I know half of the period. I know from this low, this high to this low, the distance across is 3. Okay, so I know that the distance from here to here, okay, that this distance is 3, because I'm at 2 for my max in terms of my x, and then I'm at 5. So that's 3 away. So what that means is my period is going to be 6, because it's 3 to the minimum, which is going to be 3 more. So what I'm going to do is I am going to start at this point, which is this point over here, which is 1.4567. And to get to this point here, which is going to be 6 away, I'm going to add 6 onto it, okay? So when I add 6 on to this one here, I'm going to get this point, which is going to be 7.4567, comma, -5. So that is going to be the second time that it hits that height of -5 after the first time. And to find this one here, I'm going to take the 2.5433 and add 6 onto that. And so that one is going to be 8.5433, comma, -5. That is going to be the third time I would arrive there. So my answers are 2.5433 minutes, 7.4567 minutes, and then a third time, I don't think they asked for it, but is 8.5433 minutes. Okay, number 3. So on number 3, Mrs. Ree and Miss Van Sokema find the number of students in math lab varies periodically. Assume that the number of students varies sinusoidally with time. They start at time t = 0 right after the bell, and a minimum number of 5 occurs at t = 3.4 minutes. The next max occurs, which is 40 people, at 20.3 minutes. Sketch a graph of the sinusoid, label all important values. Okay, so our time's going to be starting at t = 0, that's right after the bell. A minimum of 5 people is at 3.4 minutes. So this is going to be minutes here. This is going to be people. And our minimum is 5. They tell us that the maximum is 40 at 20.3 minutes. So the maximum is 40. So if I want to figure out the value in between, I'm going to average. I'm going to take my 40 plus my 5, my high and my low, add them together, divide by 2, and I'm going to get 22.5. So this is going to be 22.5 is going to be my center. So at this point, I know my vertical shift is here, so that's going to be my K. I know this is my high, this is my low. So if I want to figure out my amplitude, if I take 40 minus 22.5, I get 17.5. So my A is going to be 17.5. Okay, this right here is my K. Then what I know is at 3.4 minutes is when we have our low. So our low, I'll just say, is here, and that is 3.4. And so I got 1, 2, 3, 4. I'm gonna just move this out a little bit. Just give myself more space. I'm kind of scrunching myself. Okay. So 1, 2, 3, 4, 5. And again, this is going to be minutes. We know that we have a high, which has to be, so what's going to happen is, if this is going to be, this is our low, this is our low. Halfway in between is going to be our high. Halfway in between that is going to be our 0, which is our 22.5, and that one too. And that's going to be our graph. Now, I know that this high value occurs at 20.3, so this is going to be 20.3. So if I take 20.3 minus, well, here, let me do this first. If I take 20.3 plus 3.4, and then I divide that by 2, I get that this right here is going to be 11.8. Okay. Now, if I take my 20.3 and I minus 3.4, that's going to show the distance to the center, which is 16.9. Okay, so basically from here to here, from here to here is going to be 16.9. So that's going to be half of my period. So if I add that on to my 20.3, I see that I'm going to end at 37.2. And then to find that middle one, I'm going to take that, add it to 20.3, divide by 2, and I get 28.75. So this one here is 28.75. Okay. Now, since it's 16.9 to the center, that tells me my period is going to equal 16.9 times 2. So 16.9 times 2 is going to be 33.8. Okay. So now if I'm going to write this equation, I'm going to write it as a cosine. Let's see. Here they want us to express the number of people P as a function of T. Okay, so I'm going to go P equals, that's like my Y. And I'm starting at a low, so I'm going to have a negative cosine. And my amplitude was the 17.5, so I'm going to have a negative 17.5 cosine. My period is 33.8. So I'm going to go 2 pi over b equals 33.8. So I'm going to get b equals 2 pi over 33.8. And let's clean that up. Let's not leave it with a decimal in a fraction. So 2 divided by 33.8 is that, which is not very nice. So what I'm going to do is I am going to hit the math button. And when I hit the math button, I'm going to hit fraction and I'm going to hit enter. And I get 10 over 169. So I'm going to rewrite this as 10 pi over 169. Okay, I don't like having decimals and fractions. Okay, so I'm going to have 10 pi over 169 times x, and I'm going to start this right here. So minus 3.4, and then my k, okay, my k is right here or right here at my 22.5, so plus 22.5. So that's your equation. And actually, sorry, they wanted us to put a t here for time instead of an x. Okay, that's your equation. Now it says predict the number of students when t equals 8. So we're going to be putting 8 in for t. Now, what you can do on these calculators, okay? If I go to y equal and I put this into my calculator, so let me just start fresh. Okay, so I'm going to put in a negative 17.5 cosine 10 pi over 169 times x minus 3.4, close, and then plus 22.5. I can, and they want us on part D to figure out the first 2 times that they reach 25 students. So I'm going to put in 25, y equal 25. I'll deal with that in a second. I want to scale my graph to look like the graph on my paper. So I'm going to hit window. I'm going to go from 0 to, let's say 40, because I have 37.2. So let's go to 40 by, let's say 2s, 1s or 2s, doesn't really matter. my Y's are going to go from 0. My max is 40 people. Let's just say 45. And let's go by 2s again. Okay. And then I'm going to hit graph. And so here's my graph. And it's going to be graphing y equal 25, which is going to help us on part D. Okay, that's going to help us on part D. What I want to show you is you can put 8 into the equation on just a regular screen. So if I go to a regular screen, I could type in negative 17.5 cosine of 10 pi over 169 times, would they want 8? 8 minus 3.4, close, plus 22.5, making sure my calculator is in radians, which it is. And I can get 11.017. But if I'm on that graph screen and that value I want to figure out is physically on my graph, 8 is here because this is going from 0 to 40 is what I went to. Another way to evaluate on that button that we did intersect, hit second and trace. The very first choice is value. Hit that. And we want 8. Okay, and what it'll do is it'll take it to me on the graph and it'll give me the answer. So predict the number of students when t equals 8, about 11. Okay, about 11. Okay, it was 11.01, but about 11. Okay. Now, the next one that we want to do is we want to figure out when it is at 25. Okay? So if we want to know when it's at 25, the first 2 times. So the first time would be here, the second time here. So I want points of intersection. So I'm going to do second and calc again. I'm going to go down to number 5, which was intersect. I'm going to jump up to the line and I'm going to arrow over here to find the first time. And you're going to hit enter 3 times. Once for the first, once for the second, and again after this. And it's going to say 12.62. So let's say 12.62 minutes. And then we're going to do it again. So we're going to hit second and calc. And number 5, intersect. And I can just scroll across here. Hit enter, enter, enter 3 times. And the next time is at 27 point, let's say 98 minutes. Okay, and those are our answers. On number 4, you are a captain of a submarine and your first mate has just detected an enemy destroyer in the area at time t equals 0. As an evasive maneuver, you have decided to porpoise, go shallow, then deep, and so on, the submarine. At t equal 4 minutes, you are the deepest point, negative 1,000 meters. At time t equal 9, you reach the shallowest point, which is a negative 200 meters. Okay. So if I'm graphing this, we're actually below. So the shallowest that they go is going to be negative 200. The deepest that they go is going to be negative 1,000. And then halfway in between, if I add those together and divide by 2, it is going to be negative 600. So I know that at t equal 4 minutes, you're at the deepest. So if I put 4 here, we're at the deepest. So let me just real quick draw in. This is going to be my vertical shift. This shallow is actually going to be my maximum, and this is going to be my minimum in terms of the curve. So I reach the at 4, we're down here at negative 1,000. At 9 minutes, you reach the shallowest. So 1, 2, 3, 4, 5. So let me just graph this real quick. So I'm going to go low to low or deep to deep, shallow in the middle, and then in between will be our negative 600 and our negative 600. And that's our graph. Now for this, what we want to do is we want to figure, and we know that at 9 minutes, we're at the shallow. So this right here is going to be 9. And so the distance from here to here is 5. So that means I'm going to go another 5. And so that's going to be at 14. So my period is going to be 10. Halfway in between 4 and 9, average them. 13 divided by 2 is a 6.5. 9 and 14 makes a 23. And half of 23 is 11.5. And so that's our graph. Now we want to write an equation. So the equation I'm going to do is going to be a cosine. I'm going to start down here. So it's going to be negative. The distance from my, my blue to my green, that's going to be my amplitude, which is going to be 400. So I'm going to have negative 400 because I'm starting at a low. Cosine. My period is 10. So 10 is equal to 2 pi over b. So b is going to be 2 pi over 10 or pi fifths. So this is going to be pi fifths. And then we're going to times that by x minus 4, because again, I'm starting right here, and minus 600. And that's going to be our equation. Then it says your submarine is safe when it is below negative 350 feet. Was your sub safe at t equal 0? So we're going to put this into our graphing calculator. Okay, let me put in this equation. Okay, so I am going to put in negative 400 cosine pi over 5 times x minus 4 minus 600. And we want to know about it being at negative 350. So I'm going to put in y from negative 350. I'm definitely going to change my window. So my minimum, they want to know at t equals 0. So maybe I go to like negative 5. So my 0 is not like on the edge of my graph. And let's say I go to 15 because this went to 14. And I can go by ones. My y's, I need to go down to negative 1,000. So let's say go to negative 1,010, something like that. My maximum's negative 200. So let's say we go to negative 190. And let's say we go by hundreds. And then we hit graph. And so we're seeing our graph here. I want to know, okay, that's negative 350. And so if I'm looking at this, it says when t is 0, was your sub safe? Was it below 350? Well, that's 350, and that 0, it was up here. So no, it was not safe. Okay. No. And if we want to know what value that is, okay, I can go to second and help. And I can go to my number 1 for value, because I'm going to put this in for my x. I want to put in a 0. And at 0, we were at negative 276. No, we were only at negative 276.3932. Okay. Find the first time after 0 the sub becomes safe. So the first time after 0 that it becomes safe is right here. So I want to find that point of intersection. So I'm going to go second and calculate. I'm going to go down to number 5. I'm going to hop down here to the line. I'm going to hit enter once, enter twice, enter 3 times. And it's saying at 0.425. So 0.425, what was this in? Sorry. The time was in minutes. So 0.425 minutes. That is our answer. And I'll make a video for the second assignment too.